Hello and welcome to this brand new course on flat slabs. In this class, we'll be discussing about these three topics. That is, first one is what is a flat slab. We'll see the definition of it. Second, we'll talk about type of the flat slabs that are available in the market. And third, and the most important, the advantages and disadvantages of flat slabs. If you are new to the topic, please stick around. But if you already know what is a flat slab, then please carry on with the future classes where we talk about the code and the actual application of the code onto the software. All right, so let's get started. So basically, what is a flat slab? A simple definition is given here. A flat slab is a reinforced concrete slab. Okay, so basically it's made up of RCC that is supported directly by columns without the use of beams. Now, what do I mean by that is it looks something like this. Okay, so we have a slab on top, and the slab is directly supported on what? It is supported directly on columns. We don't have any beams in the picture. So when we have a condition like this, it is basically called as a flat slab. Okay, then follow up with that is it may be supported with or without a drop or with or without a column head. Now what do I mean by this is basically the second two conditions that we have over here. The first condition is this, where slab is actually sitting on a column. The second condition is this, where the slab is there and then we have something called as a drop over here. You're seeing the second portion, right? This is called as a drop, and then we have a column. Now why is this drop provided? To fight against the punching shear. Your column shouldn't punch through the slab. Okay, so to avoid that condition, what we generally end up doing is we end up taking this flat slab load, whatever load is coming, right? That load is get transferred to this area and then it gets transferred to this area. Okay, so there's a gradual transfer of load. That way what happens, your punching shear will not come into the play that much. Okay, again we have to make sure that it is safe against punching. All right, just because we are giving a drop doesn't mean it is safe against punching. We have to check for it again. Okay, so this is the second condition. The very first condition was what? That it doesn't have any beam. The second was it is supported without a drop or without a column head. Now what is a column head? I have created an image for that also here. So this is basically a column head, or it can be like this also, column head, this portion. All right, so basically what is a flat slab? A flat slab is system that is directly supported by columns and it doesn't have any beam in the picture. The second thing is it can have a drop or it can have a column head or it can have both also, no problem with that. So this is basically how your flat slab will look. We have our drops over here. This is our slab, then we have a drop, and after the top we have our columns here. And if you see, notice the difference is here what is there, the distance between the two columns is very large. Okay, here the distance is very small. Okay, so depending upon the kind of thing you're creating, depending upon that you can actually go with this method or this method. In this, basically why we're using this is basically for party halls, for malls, and for parking and all. We need larger space. So that and what do? We go for bigger drops and we go for larger span in the between the columns. In this case generally that is not the case. So what do? We end up providing smaller columns at regular intervals. Okay, either way, depending upon what you want to construct, you can go for either method. So basically this is how the flat slab will look. I just shown you in the SketchUp, right? So basically this is how they look in the real life. So moving forward, now types of flat slabs. This first portion that we have over here, if I just take you to the first diagram over here, okay, this flat slab, okay, is basically called as flat plate. Okay, that is what we have over here. One type is the flat plate slab, which is simple and economical option that is ideal for low-rise buildings. In this, what happens? In this, we don't have any kind of a drop. That is what the first condition is over here. Okay, so if you have a just a slab and a column, there is no drop in it. It is basically called as a flat plate system. Second is another type of slab which drop panels. This is basically the drop panels. Okay, we have drop panels here. This is type 2, and type 3 basically is what I have just shown you over here. Okay, we have larger spans over here between the columns. Okay, so based on that you can call this a type 3. Or what you can do, if you don't want to differentiate slabs based on this, what you can do is you can just look at this particular diagram. Okay, so we have first this flat plate. This is not flat slab, this is basically a flat plate system. Second, we have flat slab with drop panels. I have shown you this already in the SketchUp. Then we have something called as flat slab with drop panels and column head. Now column head, as I said, column head can look like this or like this. So this is basically the four type of slabs that you can find in the market. Now I'll take you to the photos that I have. Again, if you want to get a better understanding, you can see again, same thing I have mentioned over here. This is one type of image. The second image also you can see flat slab with drop panels, flat slab with drop panels and column capitals. Then we have flat plate systems. Then basically, if you want to see this in the section view, we have a slab and a column, as I have shown you in the SketchUp already, right? We have a slab and a column. Then what do we have? We have column capital. This is basically column capital. Again, I have provided drop also here. Okay. You can remove the drop and just have a capital also, no problem with that. And third option is same thing. We have a drop panel, then we have a capital. This is done basically when the punching shear is too much. Okay, the drop is not sufficient enough to take care of your punching. That time we go ahead and provide a capital also. Okay, and if there is not enough space, what we end up doing is we end up just providing column capital. If you see here, instead of drop, doing the whole thing as a drop, they just remove the excess portion from this side and this side. That's why we get the column capital thing. Okay, so let me take you further and I will show you the photographs. Again, this is from a mall in Bangalore. If you see here, we have our column. All right, this is from parking lot basically. So we have a column that is having a drop over here, and then again we have one more columns. And because these columns are too close to each other, we have a single drop for them. And then lastly, we have something called as a column with a capital. All right, all of them have been provided in one single system. Okay, it is not like this is a different project, this is a different project. No, all of them are from the same project only, based on their space available. If you can see here, there's a constraint over here, right? There's something mechanical they have put over here. So there is a constraint over here. To avoid the constraint, okay, they cannot give a drop over there. So what they have given a column capital instead. Okay, and in the back end you can see here we have a column, but there is no capital, there is nothing over there. There is basically a flat plate system and the back end. Why they have done that? Because punching is not that much over there. So based on the kind of shear you are getting, punching shear you are getting, you can either go for drop, you can either go for column capital, or you can just go for flat plate system over there. So all of them can be combined in one single system altogether. Okay, it is not like if you have drop, you have to have drops all the throughout the entire project. That is not the case. So going forward now, advantages of flat slabs and disadvantages. This is basically very simple. See, first is the decreased floor to floor height. If I can just show you over here, this is conventional, this is beam free system. Basically, when we have beams over here, if you are providing a AC duct cannot come here, bend like this and then go. Okay, that will be very difficult. So what they end up doing is whatever the beam is there, beneath the beam, they have the AC duct. So your height clearance that you have actually decreases further. In this case, that is not the problem for us because we have a slab and we have nothing else to obstruct our view. Directly, we can go for the system over here. Okay, so you can see the head-to-head space will remain same. All right, and what happens? You can actually provide your ducts and everything, and this is one of the reasons, not the only reason. The other reason is the spacing between the columns, as I have shown in the photograph. Right, where is it? Here. Okay, this is very important. The column and slab that you're providing here will continue like this till the end of the project. If you have 5-story, 10-story, they'll continue like this. So if you want to have so much of spacing, for example, we can fit 2 or 3 shops in the upper floor over here. In the bottom floor, we have parking, but in the upper floor, we can definitely fit 2 or 3 more shops. Okay, whenever the column comes, it is actually occupying a space. Okay, so to avoid that, what they end up doing is even if this thing is not there, this thing is not met, the conventional, this height thing is not met, they end up providing this so that what happens, we can have more large spans between the two columns. You can even go for PT slabs also. Some of them will go for flat slabs with PT. Okay, this is again very advanced topic, but they end up doing that also just so that they can have more space between the columns. So the very first thing is decrease floor to floor height, as I have shown you here. The floor to floor height decrease. This is 3.4 meters in the total. This is 3.2 meters in the total. Okay, and if you have 10 stories like this, you end up creating a one more story for yourself. I'll explain this when we come to this come to the e-tabs and safe part. Don't get confused now. I'll create an example over there and show it to you. Okay. Next is quicker construction time, reduce foundation load, then create column free areas. The last but not the least is more creative design possibilities. And the last point that we have, lower overall construction expenses. I generally don't agree with this. Sometimes what happens, the construction expense is a little bit more when it comes to flat slabs. It depends from project to project. But generally, because we have less number of columns here and the construction time is much lesser, we end up saving money in most cases. So these are the basic advantages that I have listed out. No one is going to ask you this in the interview. Okay, they rather ask you how to design the structure instead. But these are the few advantages that we have. And then we come for the disadvantage part. If you have a flat plate system, okay, what is a flat plate? Again, I'll just take you over here. Flat plate is something like this. Okay, so if you have a flat plate system, the distance between the columns cannot be that large. That's what they're trying to say here. Then the use of drop panels may interfere with large mechanical ducting. That is what I was showing you here, right? Large mechanical ducting which we have over here. So it will interfere it. So because of which what we have done, we have removed the drop and we have given capital instead. So this also is listed as a disadvantage over here. Then we have incompatibility with masonry partitions. See, generally whenever we have a beam, right, the beam is supporting a wall above it. That's how basically we give the beams. Okay, but here because we have no beams, if you have any partition wall that is made up of bricks or something which is very heavy material, then what happens? The local deflection can become more. Okay, so the compatibility issue is definitely there when we have masonry partitions. All right, but generally, if you see malls and all, we do not have masonry partitions. We have glass partition walls, right? We have very thin, but we have the partition made from the glass walls. So that can be easily accommodated for. But I'll show you how to create the partition walls on this flat slabs and what are the reactions going to be for those loads. Okay, because it's very important. Because in the future, if they consider to create a brick wall over there, it'll become an issue. Your flat slab should be in a state to accommodate those loads also. So I'll show you how to create masonry partition loads on the slab. Then last but not the least, a higher thickness is in comparison of typical RCC two-way slabs. Now RCC slabs generally we have 5 to 6 inches thick. That is basically 125 mm to 150 mm. But what happens is because we have shear forces acting on the structure, we end up providing more thickness. So it can be approximately 200 mm also. It can be more than that as well. Okay, so you have to keep that in mind. This is why I just said this conventional thing that I have shown you here. No, it is not true in most of the cases. Okay, because if you're having too much spacing between the columns, the kind of shear that is going to have is going to be too much. So that time what happens, the slab thickness will increase and your drop thickness also will increase. If that is not sufficient, you have to provide capital also. Okay, so even this is not true. The spacing between the columns and the kind of free area that you get is actually very good to work with. Okay, there is actually listed in advantages, I guess, greater column free areas. So because of we have more column free areas, we have more creative possibilities at our end. Okay, so this is basically the brief introduction of what is a flat slab and what can you expect from flat slabs, different type of flat slabs and all we have discussed over here. Now, from the coming classes on fourth, we'll go towards the code book first because you have to understand what kind of limitations the code book places on the flat slabs before we take you into the system and we start doing with the working on the flat slabs properly. Okay, so I hope this introduction class gives you a brief idea about what is a flat slab, the type of flat slabs that you can expect in the market, and what are the advantages, basic advantages, and what are the basic disadvantages of the flat slabs. So I hope you have a clear understanding now. See you guys in the next class. Thank you.